Hello, good morning, guys. So in the last class, we discussed about addresses. Okay. In the last class, we discussed about addresses. In those addresses, we saw two types of addresses. One is the logical address and second is the physical address. Okay. Logical address, we took the example. First of all, they can be changed, means they are not fixed. And example was your IP address. Physical address, we saw these are fixed with the hardware. Fixed with hardware. And example was MAC address. Okay, these are the two types of addresses. Then we saw about features of your IPv4. Okay, so I also discussed about the features of your IPv6. What are the differences in your IPv4 and IPv6? Your IPv4 is 32-bit, IPv6 is 128. Okay, and we saw some more differences like how the number of octets and hex states, the separation with dot and colon. Okay, and we also saw about the MAC address, that it is a 48-bit addresses, uses hexadecimal notation. Okay, and there were three ways to represent your MAC address. After that, we saw about binary to decimal conversion and decimal to binary conversion. Okay, these are the things we saw yesterday. After this, we saw about IPv4 classes and IPv4 address range. So these are things we saw yesterday. So anyone having any doubt in that part? Is it clear to everyone? Okay. So today we'll be moving forward to the subnetting. So what is subnetting? So basically, before going to the subnetting, we must know about few things. Okay, that your IP address. If we talk about your IP address, it is made up of two parts. Okay. Again, first of all, let me give you the example of a university only. This is a university. In this university, the students get enrolled and they have some enrollment number, correct? They have some enrollment number. Let's say this is some ABC university. So the first student who gets enrolled in this university, his enrollment number will be something like ABC001, correct? Then second student, ABC002, correct? And like this, maybe there will be something like ABC100, okay? So if you see, all the enrollment numbers are starting with ABC. Why? Because this enrollment number, in the enrollment number, this ABC denotes that it is the university ABC. Okay, it is defining that this particular student is student of ABC University. Okay, similarly, what happens that in your network, to identify a student, again, same example, this is your network instead of university, and instead of enrollment number, we have the IP address. Okay, let's say we have the IP address 192.168.0.1. Okay, then the second IP would be something like 192.168.0.2, because yesterday we saw that the range increases, like if the first address is 0000, then first of all the last octet will increase. Okay, so similarly these addresses will keep going on like this. So in the address also there will be something that will be defining the network. There will be a part that will be defining the network, and there will be a part that will be defining the number of the system, the address of the system. Just like in your enrollment number, the ABC is defining the name of university, that to which university this student belongs to, and the remaining part is the number of student. The remaining part is the number of student. Similarly, in your IP address also, you will have a part that will be defining the network, and the part that will be defining the network, you will call it as a network part. Okay, and there will be a part that will be defining that particular node. So that particular part is going to be known as host part. Means your IP address, similarly like your enrollment number is made up of university name and number of student. Similarly, your IP address is made up of network part and host part. So always your IP address is made up of two parts, network part and host part. Okay, it has been divided into two parts. So we combine the network part and host part, and then we get the total IP address, a full IP address. Means looking at the IP address, you can decide whether it is which part is the network and which part is the host. But how do we know? Because we haven't seen anything like that can tell us, okay, this part is the network and this part is the host. Okay, so for this purpose, we have something called as subnet mask. Okay, so again, subnet mask is the value, is the number that tells that in your IP address, which part is the network part, which part is the host part. Okay, because in total, we will be writing everything in the bits only, because your system is going to understand binary bits only. So this network part, you can also call it as a network bits, and host part, you can call it as a host bits. Okay, so how do we know which part is the network and which part is the host? We will know with the help of subnet mask. This subnet mask is going to decide whether which part is the network and which part is the host. Okay, so now we use only 3 classes for assignment purpose. Those classes are class A, class B, and class C. Correct. So if I talk about class A, what is the range of your class A? 0 to 127, because this is the first octet value we are talking about. Then class B, 128 to 191. And what about class C? 192 to 223. Okay, so these are the values. Now, if I write an IP address, let's say 10.0.0.1, which class? Class A. If I say 172.39.16.1, B. If I say 223.0.0.1, class C. 223 belongs to class C. From 2 to 4, it will start with class D. Okay, so you know about the class now, but in each and every IP address, we say there is a network part and host part. So to define that network part and host part, we have subnet mask. Okay, so for each and every class, for class A, class B, and class C, a default subnet mask has been defined. For class A, B, and C, a default subnet mask has been defined. For class A, the default subnet mask is 255.0.0.0. Okay. For class B, it is 255.255.0.0. For class C, it is 255.255.255.0. So this is the value of default subnet mask for your classes. But what exactly is your subnet mask? So if you want to define your subnet mask, you can define it like your subnet mask. It is a 32-bit binary number that differentiates between your network part and host part of an IP address. Your subnet mask is simply going to tell you about which part is the network and which part is the host. Okay, so note this down. This side you can say class, and this is the default subnet mask. And if you want to define your subnet mask, you can define it as subnet mask is a 32-bit binary number that is used to, or simply you can say that differentiate between network part and host part of an IP address. This is your subnet mask. Okay, and these are the default subnet mask values for class A, B, and C. Okay, only your class A, B, and C are going to have the subnet mask. D and E are not having subnet mask because we do not use them for assignment purpose. Okay, I have started the recording, right? Okay, all right. This is clear. Subnet mask is clear. Now, when I say your subnet mask differentiate between network part and host part, so how does it do that? How do you know which part is the network and which part is the host? So before going to this, I'll show you that these default subnet mask values, even if you don't provide in your system, they will automatically tag it. Okay, so I can say class default subnet mask. First is the class A. For class A, default subnet mask is 255.0.0.0. Then for class B, it is going to be 255.255.0.0. And for class C, it is going to be 255.255.255.0. Okay, so what I'll do, I'll try to assign addresses from these classes to my system, and we'll see your system is automatically taking the subnet mask according to the class. Okay, okay, so I have to provide the IP address. First of all, I'll provide IP address for class A. So this is for class A, correct? Now I'm not going to type anything in my subnet mask. Below this, we are having the subnet mask. I'll just press tab, and do you see it is automatically taking the default subnet mask, correct? Similarly, if I give the address for class B, so let's say I give the address 172.16.0.1. This is a class B address. If I hit tab, it is taking 255.255.0.0, correct? And if I give a subnet mask, address for class C 192.168.0.1, this is class C. And if I hit tab, it is taking the default subnet mask for class C. Okay, so these are the default subnet. Yes, please.
Is there any chance to override the subnet mask?
Yes, we can do that. And we'll be doing that when we are doing the subnetting. Right now, we are just seeing the default case and we are understanding how your subnet mask is telling your system that which part is the network and which part is the host. Okay. This alone subnet mask, this is delivering a lot of information. First thing, which part is the network and which part is the host. And this is also telling your system that in your network, how many other systems are there? How many other systems are there in your network? Okay, so this information is also delivered by your subnet mask. And we'll be seeing how it is delivering that information. Okay. So the default values are clear. Okay. Now see, I'm taking an example of class A. This is an address of class A. Correct. And if I write default subnet mask for class A, it is 255.0.0.0. Okay. So this is IP address. Okay. And this is subnet mask. Correct. Now I'll write these in binary. Okay. I'll write them in the binary. So if I write 10.0.0.1 in the binary, what will be the value for 10? Is it 10? Yes or no?
Yes.
10, right?
Yes.
Now dot for 0, all 8 will be 0. I mean, again for 0, all zeros. For 1, this is the value. Now if I convert your subnet mask in the binary, it will be 255 means all 8 ones. Then this is the subnet mask in the binary. Okay. So if you write your subnet mask in the binary, then you can easily tell from your IP address which part is the network and which part is the host. So in your subnet mask, anywhere you see the 1 in your subnet mask, where you see the ones, they are your network bits. Okay. Your network bits are represented by 1. And your host bits are represented by 0. Okay. So looking at this, you can say these bits are the network and these all bits are the host. Okay. Now, if you compare this thing with the IP address, so means this part of your IP address, it belongs to the network and the remaining part, it belongs to the host. Okay. You just need to compare your IP address with the subnet mask. In your subnet mask, the number of bits that are denoted by 1, they are your network bits. And the same number of bits in your IP address, they will become your network. So if I see here, can I say that the first octet belongs to the network? The first octet, because the first octet in your subnet mask completely 1. So means this octet belongs to the network and the remaining 3 octets, they belong to the host. So means in this is my network and this remaining part is host. Okay. This part is the network and this part is the host. So always remember, whenever we are designing a network, okay, so you came to know that, okay, this part is the network. So your network part is going to remain the same throughout your network. Your network part is going to remain same throughout your network. Now, what do I mean when I say it is going to remain same? Means from the first address till the last address of the network, it is going to remain same, 10 only. It is not going to change. Then what will change? The host part. The host part is going to go from minimum to maximum. So what would be the minimum value of these all bits? 0 means the first address of my network would be 0. Then the next address would be 1, 2, and then somewhere it will be 255. Then I will have to say 1.1.0, if you remember the yesterday's part, and then it will be 1.255. Similarly, there will be a time it will be 255.255, and then it will be 1.0.0, and there will be a time when it will come to an end, and all these 3 octets will become the maximum. So this is an entire network of class A. This is an entire network of class A. So always remember, in a network, your network part is always going to remain the same, and your host part is going to start from minimum and go till maximum. Okay, this is how you find the network range, that how many IP addresses are there. Just looking at the subnet mask. Looking at the subnet mask, we came to know which part is the network. So we will keep the network part constant. And if you change the host part to 0 minimum, that will be the first address. And if you change the host part to maximum, that will be the last address. And all the addresses in between, they will belong to that particular network. Okay. Now in your IP address, if you see the first address is this, means this will be known as your network ID. If somewhere you have to represent this network, whatever network you have designed, then you will be using this ID. If someone asks you which network you are using, we are using 10.0.0 network. Okay. This is how you represent a network. Again, let me give you an example of class C. So for easy understanding, then we'll come back to class A and B. Same calculation. Let's do for class C first. So I'm writing an address 192.168.0.1. Simple. And default subnet mask 255.255.255.0. Now, if I write this in binary, so 192 is 11, this value, and 168 will be 128.32.8. This will be the value for 168. Okay. And then this is the value for 1. Again, if you write your subnet mask in binary, this will be 8 ones. This will be also 1. This will be also 1. And last part, this will be 0. Again, looking at the subnet mask, we came to know the first octet, it completely belongs to the network. Second octet also network. Third octet also network. Why? Because we know network bits are represented by 1 and host bits are represented by 0. So this part will be the host. So the last octet belongs to host, correct? Compare the subnet mask, the IP address, compare with the IP address. So we'll come to know that these 3 octets completely belong to the network. Means these 3 octets are going to remain the same throughout the network. Okay. So if I have to write the first address of this network, how I'm going to write? So if I want to write the first address, my network part is going to remain the same, 192.168.0. Okay. Now for writing the first address, I'll take my host part to minimum. So what is the minimum value of 0? Okay. Then the second address would be, again, my network part is going to remain the same. It will be 1. Correct. Similarly, 192.168.0.2. And similarly, in the same way, 192.168.0.254. And the maximum value can be 255. So now it is maximum, and network part we cannot change. Okay. This part is going to remain same throughout the network. Why? Because this part belongs completely to the network. 3 octets completely belongs to the network. So this part is not going to change throughout the network from starting till end. Only your host part will start from minimum and go till maximum. Okay. So if I want to represent this network, what is my network ID here? The first address of my network. This is my network ID. So what will be it will be network ID. And from 1, I can always remember this network ID you cannot use to assign in your system. You cannot assign this address in your system. Your system will not allow. Okay. Your system will never allow you to assign the first address and the last address of your network. Means you cannot assign this IP and this IP. Why? Because it is reserved to represent the network. It is reserved to represent the network. It is the network ID. And this is reserved for broadcast address. Remember broadcast, one-to-all communication. So if I want to deliver a message to everyone in this network, I'll simply go and send it to this. Or if I ping this network, if I ping this IP, it is going to reach each and everyone in my network. Because what is broadcast? One-to-all communication. Is that clear? And the remaining part, the remaining addresses in between, they will be known as your valid IP. Valid IP in the sense, these IPs you can assign in the system can be assigned to nodes. Is it clear?
One doubt, Ajay.
Yes, please.
Is it only for the private IPs?
No. For the public IP also the same.
Okay. So
No.
because you're taking all the examples from private.
Yeah,
so
because these IPs mostly most of the people might have seen in their daily routine, so they'll get familiar.
Okay.
Otherwise, this concept is same for the public or private.
Okay.
And we also haven't discussed about the public and private concept. So right now, I don't want to confuse anyone.
Okay.
Yes. Okay.
So, sir, if we think for that broadcast IP,
It is going to reach each and everyone,
during the time.
every node. This is clear. First address will be network ID. Last address is going to be broadcast address, and the remaining addresses, they will be your valid IP. So now I'll show you practically that you cannot assign this address as well as this address. Okay. So let me try to assign 192.168.0.0. Subnet mask is automatically taken. If I say OK, it is going to give me an error. The combination of IP address and subnet mask is invalid. Why? All of the bits in the host address portion of the IP address are set to 0, means it is the minimum. host part is minimum, and that is reserved for the network ID, so we cannot use it. Similarly, if I try to assign 255, so this is the last address. So this time it is going to say the host part. See, all of the bits in the host portion of the IP address are set to 1. And when all bits are 1 means maximum value of host part, and that will be reserved for your broadcast address. Okay, I can assign anything in between. I can assign here 1, and it will be taken without any error. Similarly, I can assign 254, that will also be taken. But I cannot assign the first and the last address. See, only there is a problem with the first and the last address because they are reserved. See, I cannot use the first address and the last address. Is it clear? Okay. So this is clear for class C. About class B, let's take same example for class B. So I'll write an IP address 172.16.0.1. Okay, or let me say 168. That is fine. Any address you can take 255.255.0.0. This is the subnet mask. Again, if you see here, if you write this in binary, so what will be the binary for 172? 128 plus 64 is 192. Okay, so for 172, I think 10, 10, 10, 160, 168, and 1000. Is it? Check the binary for 173. 128, 32, 160, 168, 172. Is it correct? Okay. And then if you write your subnet mask in binary, so is it already 8? 3 and 5, 8. Okay. 10101 1001248. Okay, this is correct. Okay, so again, if we look at this address, we will come to know this is the network. Again, this is the network, and 2 remaining are host. So if I want to write the first address, I know here that my 2 octets are for network and 2 octets are for host. Okay, so I'll have to keep the 2 octets constant, and the 2 octets, my host part is going to change from minimum to maximum. Okay, so the first address would be 172.168.0.0. This will be my first address. The second address would be 172.168.0.1, and then somewhere it will be 172.168. Let's say 0.255. Next will be 172.168.1.0, like this. And by the end, it will be 172.168.255.254. And the last address would be 172.168.255.25. Okay. Again, the first address, it will be reserved for network ID. The last address, it will be reserved for broadcast address. And all the IPs in between, they are valid IPs. Okay. And these IPs you can assign in your system, in your nodes. Is it clear? Okay. Do I need to show practically whether they are being accepted or not? I can show you.
This is used for pinging. What is the purpose of network ID?
Network ID. When, let's say, we are defining a network, when we'll be doing the routing. In that routing, we will be defining a route for a particular network. So that time, how we are going to represent that network? There will be using this network ID. Okay. So once we start with the routing, we'll be coming in use for the network ID. Okay. Because for sending data from a data packet from one network to another network, a router needs to know how to reach there. Okay. So for representing that network in the path, we'll be using this network ID. Okay. This is clear. And now about class A. So in case of class A, we have taken this address. Looking at this address, we came to know that, okay, first octet is the network and remaining 3 octets are the host. So means I have to keep this constant, and remaining will change from minimum to maximum. So the first address will be, this will be constant and host part will be minimum. Second address 10.0.0.1. And at the end, it will be the host part will become maximum. there will be a time when 10.255.255.254 will be there. The last valid IP 10.255.255.255 will be there. Okay. So again, the first address, it is going to be your network ID. This is going to be your broadcast address. And this, all the addresses in between, they are going to be your valid IPs. Is it clear? Yes or no? Okay. This calculation is for class A. This is class C and class B. Okay, so now you know how you can calculate by looking at the subnet mask. If you are given an IP address and a subnet mask, you can easily calculate the range, right? Okay, let's do an example. Which class? B. So what will be the default subnet mask? Now directly, instead of writing binary, directly looking at this, you can know that 255 means all ones, 255 means all ones. So means 2 octets directly for the network, and remaining 2 octets, they will be for the host. Okay. So means you have to keep constant these two 163.0, and the host part, you have to bring it from minimum to maximum. Okay. So if you are going to write the range, the first address will be this. The second will be 0.1. What will be the last address? This one. And if we talk about second last address, 255.254. This is the last address. And here, this is your network ID. And this is your broadcast address. And all the addresses between, they are your valid IP. Okay. So you can say like, okay, this is the last valid IP. And that will be the first valid IP. Okay. So this is easy. This is clear. Okay. Now, one more thing you must remember about your subnet mask is, just make a note because that is important. In subnet mask, all ones will be on the left and all zeros will be on the right. Okay, it will never happen that first ones are coming, then zeros, then again ones, then again zeros. Okay. In case of subnet mask, all ones will always be on the right, left, and all zeros will always be on the right. This is clear. Now, looking at the subnet mask, okay, looking at the subnet mask, can you tell me, in case of class A, how many network bits are there? 1, 8 bits. If you see this subnet mask, there are 8 ones, means total 8 bits are for network. And how many bits are there for host?
24.
24. What about class B? 16 and 16. What about class C? 24 for network and 8 for host. Clear? So this is also, you must note. Okay. So class, network bits, host bits, and default subnet mask. Okay. So for class A, network bits are 8, host bits are 24. And the default subnet mask is 255.0.0.0. For class B, we have 16 network bits, 16 host bits, and default subnet mask is 255.255.0.0. For class C, we have 24 network bits and 8 host bits, and the default subnet mask is 255.255.255.0. This is clear. So everybody understood? Online people having any doubt in this part?
No.
Okay.
No. No, sir.
Okay. This is clear. Now let's go back to the presentation and see what are the things there. So first of all, subnetting. Subnetting we'll be discussing, but before subnetting, we must know something about the network bit, host bit, and subnet mask. Okay. So what is the network bits? It represents the network to which a machine belongs. Like your in the enrollment number, like you had the ABC. Similarly, in your network or in your IP address, the network bit, it is what? Something that represents the network to which a machine belongs. Okay, if a machine is having an IP address 192.168.0.1 and having the subnet mask 255.255.255.0. So looking at this, we can simply say that it belongs to the network 192.168.0.0 because the first address is going to represent the network. Okay, 3 octets for network, last octet for host. When we set the last octet to minimum, it will be our network ID, correct? What is the host bit? Host bit represents the IP address. What is the actual address? Let's say if you are having this one, means this one is the address of that particular machine. Okay. What is a subnet mask? A value which helps to identify the network portion and host portion of an IP address. And if you write it in binary format, it consists of continuous ones. First of all, there will be all ones and then continuous zeros. All ones will be on the left, all zeros will be on the right. And in your subnet mask, the network bits are represented by ones and the host bits are represented by zeros. Easy? Okay. Now about the default subnet mask. So we have already seen these things. For class A, what is the default subnet mask value? 255.0.0.0. Okay. And if you write it in binary, 8 ones and all rest of our zeros. So can we say the first octet is for network and remaining 3 octets are for the host? Similar for class B, 2 octets are for network and remaining 2 octets are for host. Why? Because default subnet mask is 255.255.0.0. And in binary, all ones, all zeros, and all zeros. So if you see these default subnet mask values, all ones are on the left and all zeros are on the right. Correct? Similarly, for class C, 3 octets are for network and last octet is for host. In 3 octets, we will be having ones. The last octet will be having zeros. And in decimal, 255.255.255.0. And here ones represent the network and 0 represent the host. Okay. So this is about class A. We are doing some calculation for class A. We must know that, okay, we have designed the network, but how many addresses are there in one network? Because when we will give, let's say, if to a system, I give a class A address 10.0.0.1. Okay. And then I give the subnet mask 255.0.0.0. So how my system is going to know how many other systems are there in my network? Okay. So that calculation we are going to do right now. Okay. Even though we have seen that the range it is going to be from 10.0.0.0 till 10.255.255.255, but we don't know the number, that how many addresses are there. Okay. So we'll be seeing that part. See here, class A. So this is class A. First octet is for network and remaining 3 octets are for host. Okay. Network bits are total 8 and host bits are total 24. So if you want to calculate the number of networks, that how many networks you can design in your class A. Okay. We are talking about class A here. So in class A, how many networks can be designed? So in case of class A, how many network bits are there? If you remember, 8. And how many host bits are there? 24. Correct. So we have total 8 available bits. And if you remember yesterday, while we were calculating the range. So in case of class A, the first bit was always 0. That was fixed. We cannot change that bit. So out of total 8 bits, how many bits will be remaining? 7. Because we have first bit is fixed and that is always 0. So we cannot use that bit. That means we can only manipulate 7 bits. Okay. So with the help of 7 bits, how many networks we can design? Then simply calculate 2 raised to power 7. Okay. 2 raised to power network bit. So total will be 128. Means in case of class A, how many networks you can design? 128. But how many networks you can use? They are, again, if you remember, the 0.0.0.0, we do not use, and 127.0.0.0 we do not use. These 2 networks we do not use. So again, we will have to reduce 2 more because these 2 are reserved. So total, how many networks are there in class A? 126. So in case of class A, you can design 126 networks. And if you remember yesterday also, we saw this range 1 to 126. Okay. Now we want to know that in one network of your class A, how many addresses are there? Okay. We know the range that, let's say it is going to start from 10.0.0.0 and it is going to go until 255.255.255. But how many total addresses are there? So how many host bits you have here? 24. Simple. The number of bits, just write in power of 2 and you will get the number. You don't need to remember this exact number, but you must know that it is 2 raised to power 24 that we have to write in power of 2. Okay. Then again, first address and the last address. First address is the network ID and the last address is the broadcast address. These two we cannot assign, so we will have to reduce these two also. So the usable IP addresses will be whatever the number is coming minus 2, because we have to reduce the first and the last address. First address is reserved for network ID, last address is reserved for broadcast address. Okay, so this will be the number. Or if you want to write easy, you can say 2 raised to power 24 minus 2. This is it. Clear about class A? You can note down if you're not. And I have already shared this presentation in the drive, so you can have the access. Okay. So you can just, yes. So you can check from the presentation also later. Clear? Any doubt? Similar calculation will be there for class B and class C also. Let me know once done. Now see. So according to this, if we write the range, this is the range for class A. We are taking an example of a network of class A, that is 10.0.0.0. So starting from 0 and host part going till maximum. Your network part is always going to remain the same throughout the network from start till the end. Only your host part will start from minimum and go until maximum. Then the first address is going to be your network ID, last address is going to be your broadcast address. And all the addresses in between, they will be your valid host address or valid IPs. Okay. Now similar calculation will be there for your class B also. So in case of class B, 2 octets are for network, 2 octets are for host. Total 16 network bit and 16 host bit. Now, if you calculate the number of networks, so we have total 16 bits. But if you remember, again, when we were dividing the classes, so 2 bits were reserved, the first and the second bit. The first bit was always 1 and second bit was always 0. So we cannot use these 2 bits. So we'll have to reduce these 2 bits, and total bits we will be having is 14. So the number of networks you can design in your class B is 2 raised to power 14, means 16,384. Okay. These are the number of networks you can design in your class B. If you want to know how many hosts are there in one network, how many addresses will be there. So total 16, because network bits are 16 and host bits are also 16. So host bits are 2 raised to power 16. Host bits are 16. So if you calculate the number of hosts per network, you will be saying 2 raised to power 16. Okay. And again, we have to reduce the first IP and the last IP. Okay. So this will be 65,534 for class B. This is clear. Okay. You can note down from the presentation I'll be sharing. Okay. I have already shared actually. Then the address range, you can see 2 octets are going to remain the same, and the remaining 2 octets, they are going to go from minimum to maximum. The first address is going to be your network ID, last address is going to be your broadcast address, and all the addresses in between are going to be your valid IPs. Okay. And there is similar calculation for class C also. Now, in case of class C, we have 24 network bits and host bits are 8. And in case of class C, how many bits did we reserve while dividing the classes? 3 bits. First bit was 1, second bit was 1, third bit was 0. Okay. So here your network bits are 24, host bits are 8. So out of 24 bits, first 3 bits were reserved. That is 1, 1, and 0. First octet range, when we are calculating the range for class A, B, C, D, and E. That time we did the reservations, right? So 3 bits were reserved. So if you reduce 3 bits, it is total 21 bits are left. So you can say the number of networks is 2 raised to power 21. Okay. And number of hosts per network. So we are having only 8 bits. So 2 raised to power 8 will be the number of hosts in one network. And again, we have to reduce 2 because first IP and the last IP we cannot assign. So the usable addresses will be -2 and 254. Okay. Again, the address range we have. So 3 octets are for network. So they will remain the same. And the host part will go from minimum till the maximum. The first address will be network ID. Last address will be the broadcast address. And all the addresses in between, they will be your valid IPs. Okay. The valid IPs only you can assign to the nodes. Okay. So this is clear about class A, B, and C. Okay. Now, whatever we have studied so far, just a quick brief about that. In case of class A, 1 octet will be the network and remaining 3 octets will be the host. Okay. So network bits represented by all ones. So ones and remaining 3 zeros. Correct. Then the subnet mask, this is the default subnet mask values. Now you have something called a slash value. What is the slash value? Or you can say slash notation. Sometimes you'll know it as a CIDR notation. Okay. Or prefix length. These are the names of the same thing. Okay. So what is the slash notation or slash value? you have to write the slash, and in front of the slash, you simply write the number of network bits. That is your slash value. In case of class A, how many network bits are there? 8. So it is /8. Okay. So network bits are 8, host bits are 24. If you want to calculate the number of networks, so only we have 7 bits for manipulation because 1 bit is always 0. Out of 8 bits, 1 bit is always 0. So we have 7 bits. So total 128. Now the network 0000 and 127.0.0.0 we do not use. So we will reduce 2. So total 126 networks are there. In case of class A, number of hosts. So total host bits are 24. So simple 2 raised to power 24 minus 2. That's it. Okay. In case of class B, 2 octets are for network, 2 octets are for host. Means 2 octets will be all ones, 2 octets will be all zeros. In decimal, it will be 255.255.0.0. Now, if we want to write the slash value, so we see total 16 bits are network. So means /16. So network bits are 16, host bits are 16. If you want to calculate the number of networks, so in case of class B, 2 bits were reserved, 1 and 0 starting. So only 14 bits will be left. So 2 raised to power 14 will be your number of networks. Host bits are 2 raised to 16. So number of hosts per network will be 2 raised to power 16 minus 2. Okay. Then we have the class C. In case of class C, 3 octets are network, 1 octet is for host, means 24 network bits and 8 host bits. In case of decimal, 255.255.255.0. Then 24 network bits means slash value will be 24. Okay. So network bits 24, host bits 8, 3 bits are reserved, 110. So 2 raised to power 21. And we have 8 bits. So 2 raised to power 8 minus 2. Because first address and last address we do not use. This is the calculation about class A, B, and C. So anyone having any doubts so far in these classes? Whatever we have discussed today, any doubt? Online people?
No, sir.
Okay. Then we have one more concept, a small concept about public and private addresses. So what are these public and private addresses? So see, your IPv4 is not sufficient. Okay. And yesterday, or I think day before yesterday, when I show you the book, they show that to prevent exhaustion of your IPv4 addresses, they came up with first thing IPv6. Second is CIDR notation. Okay, classless interdomain routing. And the third was NAT, network address translation. And this NAT technology, it allows the use of your private and public addresses. Okay. So means your IP addresses, your IPv4 addresses, they have been divided into private addresses and public addresses. So what are the private addresses and what are the public addresses? See, if I give the difference, so let me just open the paint. So I'll give you slight difference between public and private. Public address, private address. Okay. So your public address, first of all, they are paid. Means you have to pay to use a public IP. You cannot assign yourself. And these addresses, these are free. Okay. You can use them any way or any number of addresses you can use from the private. Then if we talk about your public address, these are purchased from the ISP. Your public IP, you have to purchase from the ISP. And your private addresses, these are assigned by network admin. Means network administrators, they can assign according to their will. They can take a private address from class A, class B, or class C. Okay. Certain range of IPs have been decided in class A, B, and C that these will be the private range. Okay. And the remaining, all the range, it is the public range. Okay. So the main difference comes, your public addresses, they are routable on the internet. Means you can use the internet using the public IP, but you cannot use internet using your private IP. Okay. Not routable on the internet. Okay. One more difference. These addresses, they are globally unique. Means your public IP address will not repeat anywhere in the world. Your public IP address will not repeat anywhere in the world. But your private address, these are unique only in LAN. Only in the local area network, your private addresses are unique. Okay, means if I'm using some private addresses here, the nearby company is also using the same addresses. And there's no problem. Why? Because they are the private addresses. So it means, understand, this is my company. Okay, and I'm using a router in my company. With this router, I'm designing a small network. Okay, and there I have the host and departments and everything. Similarly, there can be a nearby company and maybe they have their own network, correct? Now they can be using any IP according to their choice. They can be using, maybe they are using the network 192.168.0.0. So maybe the same network is being used by company 2 also. Okay, this is organization 1 and this is organization 2. So maybe they both are using the same range. It will not affect them. Why? Because they are not connected to each other. So whatever addresses are there, it is unique from them. And whatever addresses are being used by the organization 2, they are unique for them. So it is not affecting them. The communication between their systems, it will not affect. Why? Because it is not connected. Correct? Means they are using the private range. In the private range, they can use anything. They can use any network. Now, let's say they want to use the internet. So internet is common for everyone. Internet is common for everyone. So now if I take a connection from the internet and this organization 2 also is having a connection from the internet. So now I need a unique address. I need an address that is unique in the entire world, that is not repeating. So for that purpose, I'll contact my ISP and the ISP is going to provide me a public IP. Okay. So what generally happens that just take a general example. You take a switch, you connect 2 systems or 3 systems. You assign them IP address, any IP address of your choice. Okay. So they will start communicating. They will start communicating. Why? Because we can use any address of our choice and we are not going on the internet. But if we want to go to the internet, if you want to take connection from the ISP, internet connection. So for using the internet connection, you need a public address. To use the internet, you need a public address. So your ISP is going to assign you public address here and also to the other organization. And these addresses that will be unique. Maybe this will be 200, 200, 200.1, and this will be something like 200, 200, 200.2. Okay. Now these addresses are unique. Means all the systems from this organization for going on the internet, they will use this address. And all the systems in the organization 2 for going on the internet, they will use this address. So when they are going on the internet, they are still unique. Why? Because they are using their public address for going on the internet. But for their local communication, they are using their private addresses. So private addresses, they are used for the local communication and the public addresses, they are for the internet. Okay. So concept for public and private clear or not? Let me show you practically. So if I show you my IP here, let me go to the command prompt. Instead of command prompt, I'm directly.
Ajay, I have a question. Is it more kind of that public address is more kind of firewall?
No, it's
like
not a
that-
firewall, it's just an address only.
Okay.
Okay, just simple IP like your normal IPs. So let me show, and then if you have a doubt, you can ask again. Okay.
Okay.
So right now, let's say I'm connected to the Wi-Fi. Okay. So for my local network, I'll be using some IP. So what IP I'm using? See here, 172.16.3.102. Which class? B. Okay. So I'm using a class B address, and it is in the range 172.16.3.102. Okay. Now, if I check my address on the internet, for going on the internet, what IP address I'm using? So I can just go and say, what is my IP? This is my IP on the internet. Is it similar with my private IP? 172.16.3.102? No, right? I'm using some other IP. Okay. So who is doing this translation? My IP is 172.16, but for internet, I'm using 104.28.252.170. So who is doing this translation? Because my actual IP is different, right? But I'm going on the internet with a different IP. So means someone is changing my IP in between. So who is changing? Your router. Okay. Your router is performing NAT, network address translation. And what is network address translation? Converting or translating an IP address into another IP address. So it is translating my 172.16 address into 104.20 address. Okay. And when I'm getting the response from the internet, it is changing from this public IP back to my private IP. We'll be discussing about NAT, and I'll show you the configuration also, how you can configure the NAT. Okay. So Is it clear? Any doubts?
We are going to do the internet by class A.
Hmm? IPs?
Class A.
Yeah, because that has been assigned by my ISP, right? That has been assigned by my ISP. When we are taking mobile data connection, when you do mobile data recharge, you can go and check in your phones also. You will be getting a public IP. Without public IP, you cannot use the internet. Okay. And maybe you will be getting IPv4 or IPv6. That depends. Okay. In your IPv6, we are not having such concept like a private and public concept. Okay. There is different concept, global unicast and unique local. So that we'll be discussing when we are discussing about IPv6. So right now, just we need to focus on the public and private addresses. Now, how do you know which addresses are public and which addresses are the private? So there is a certain range defined or certain number of networks reserved for private. This class C, yes. This is subnetting. We haven't done yet. We'll be starting tomorrow itself. Okay, because subnetting is done to reduce the wastage of IP addresses. Again, IPv4 has limited number of addresses, 4 billion. Okay, and we are already having more than 4 billion devices. Okay, so to reduce the addresses, to wastage of addresses, and to efficiently assign the addresses, we are doing the subnetting. Okay, so we'll be discussing about subnetting tomorrow. Subnetting is entirely playing with your subnet mask. You are changing the subnet mask only. Okay, now we will not, like, we will no more be dependent on the classes. We will become classless. Okay, because if you see here, we have to discuss about two types of subnetting. Subnetting means dividing the network to economically assign the IP addresses. Forget this, but right now we have to discuss two types of subnetting. One is the class full subnetting and one is the class less subnetting. So class full is what? You are simply using the default subnet mask. Whatever calculation we have done right now for class A, B, and C. Whatever calculation we have done for class A, B, and C today, that was your class full subnetting. Okay, because we are using the default subnet mask. Now we'll be doing class less subnetting tomorrow. Okay, in classless subnetting will not be dependent on class. That is why its name is classless. Okay, whenever you go or you change the subnet mask from default subnet mask, that will become totally classless subnetting. Okay, and we'll see what is the effect of your classless subnetting on your network size. Okay, all right. So about the private and public range, see here. In case of class A, okay, one network is reserved for private addresses. Okay, which network is reserved? It is the 10 network, means starting from 10.0.0 till 10.255.255.25. This is reserved for class. In case of class B, total 16 networks are reserved for private addresses, starting from 172.16.0.0 till 172.31.255.25. This is the reservation in class B. Means if you see any IP address from this range, that is the private address. Okay, and why I'm saying 16 networks are reserved? Because in case of class B, total how many network octets? 2 octets. So if you see the network octet is changing, means total network is changing. So from 16 till 31, how many? 16. Okay. Class C, total 256 networks are reserved for private. And the range is 192.168.0.0 till 192.168.255.25. Okay, this is the private range for your class C. So what could be the possible public range? Okay, here I'm showing. This is the private range. Now, if we talk about your public range. So from the total range, if you subtract the private range, it will give you the public range. Okay. So the total range of your class A is, what is the total range? From 0 till 127. Now 0 and 127 we do not use. So 1 to 126. So means my first network will start from 1.0.0. Correct. And before 10, because from 10 my private address will start. So before 10 I'll be having something called as 9.255.255.255. Correct. Until here. Then from my 10 network is reserved. So after 10, I'll have one more network, 11, and it will go until the end till 126 because no more reservations. This is your class A public range. Then about your class B. So your class B range start from 128, correct? So 128.0.0. Now before 172.16, there will be 172.15. So 172.15.255.255. And then after 31, there will be 172.32.0.0 until the end. That is 191.255.255.255. Is it clear? This is class B. For class C, it is going to be, so your class B starts from 192, correct? So before 192, 168, there will be 192, 170, 167. Okay. So it is going to, first of all, start from 192.0.0.0. Okay. And it is going to end at 192.167.255.255. Then 192.168.0 till 68.255. They are reserved for private. So next will be 192.169. So it will be 192.169.0.0 till the end 223.255.255.255. This is your public range for your class C. Okay. From your total range, you just have to subtract the private range and you will get the public range. So just looking at the IP addresses, if the IP address is starting from 10, it is class A private range. If it is starting from 172.16 or 172.31, between this range, this is class B private range. And if it is 192.168.0 till 255, then it is class C public range. Private range. And any address other than this range, that is your public address. Anything other than your private address, that is your public address. So public and private concept clear, and the range. Online people, any doubt in this part? Okay, then tomorrow we'll be starting with the classless subnetting. Okay, I'll give you some examples for classful subnetting, like how you can do the classful subnetting. We'll do some examples for that. Okay, and what type of questions you can get in the subnetting. Those questions we'll be seeing, and then we'll be going with the classless subnetting, and we'll see what kind of questions you can get in the classless subnetting. Tomorrow we'll do that. Okay. So practice today's session because it will be really helpful for tomorrow's class. Okay. Okay. So any doubts? No? Online people? No? Okay, then I'm done for the day, guys. So we'll meet tomorrow. Have a great day. Bye.